Greetings and welcome once again to my new calculus channel. My name is John Gabriel, and today I'm going to discuss the reasons for why that very well-known constant, which you call the number e, is not actually a number. It's not a number any more than pi is not a number, or square root 2 is not a number. Neither pi nor square root 2 nor e are numbers. And there's been a lot of misguided information the past few decades by academics who've never really understood uh, what a number is, never mind mathematics as a whole. Okay, so I'm going to explain to you now very quickly, or as quickly as I can, why that mathematical object you think of as e is not a number. So let's begin. Now, on the screen you will see various graphs. Okay, you'll see the graph of x squared plus 1, which is just a parabola. You'll see a binomial graph, this one that I'm pointing to here and moving, 1 plus 1 over x to the x. You'll see another binomial graph, 1 plus x to the 1 over x. And both these graphs have something special about them, as you'll see in a moment. So, mainstream academics love to imagine that when we do that, this distance here, this green distance here, is the number e. But it's not a number, it's a magnitude e, okay? Because in order for it to be a number, this particular ratio here of the green line to the gold line, okay? So the green line to the gold line would have to have a measure. It doesn't, okay? That's, after all, what a number is. A number is a name given to a measure that describes a ratio of magnitudes, nothing else. So if a ratio, first of all, in order to be measurable, a ratio needs to have quotientness. And for this, you need to visit my previous video to understand the concept of quotientness. Vitally important. Even the moronic modern Greeks of the last few decades didn't understand that concept. In fact, they don't even have a modern Greek word for it. It's called pilikotita. This isn't old stuff. This is stuff that you need to know. Otherwise, you cannot understand the concept of number. So, the first thing we need to determine is, does a ratio of magnitudes have quotientness? Another way of saying it is there a line segment, any line segment, including the antecedent and consequent of the ratio, that measures both of them, okay? When I say measures, divides exactly without a remainder. That's what quotientness is. So if there isn't, guess what? You can't measure it, because the next step is algebraic. The next step involves counting the number of pieces that fit into each part of the ratio, and that is what gives you the number. Okay? So now, let's look at some of the big problems with misguided and incorrect mainstream ideas. First of all, there is only one value of x for which we can evaluate e to the x, and that's x is equal to 0. Okay? Why? Because the series e to the x cannot be evaluated for any other value of x, since you'd need to be able to accomplish a supertask. But with x is equal to 0, you're not accomplishing a supertask. You're just ignoring all the terms in x, and you're ending up with 1. See? Okay, you're ending up with 1. Over here, I'm sorry. Right there. Okay? You're ending up with 1. That's why you can evaluate it, and it is defined, right? For any other value of x, e to the x does not result in a number. Now, limit theory is problematic, always has been, full of flaws and misconceptions. Limit theory posits a number whose existence is unproven and is assumed solely on the basis that the series converges. Okay, so just because a series converges doesn't mean that the limit is a number. Okay, if you look at this blue function here, which is a parabola, as we approach 0, it does converge to a number. That number is 1. Okay, but as you can see, there is no number here, even though we're looking at the limit. There is no number. Okay, of course, if you have to take the actual limit, supposedly you'll get e. But e is not a number, it's just a symbol. Okay, e is a symbol. So if you have to put 0 into the series, I'm sorry, yes, if you have to put 0 into either one of these binomial functions and take the limit, well, actually in the first one, in the second one you need infinity. Okay, so they're actually, one's expressed in terms of approaching 0 and the other one in terms of infinity. Let's just look at that quickly. So this one, the red one, this red one here, is approached is expressed in terms of approaching 0, whereas the orange one, this one here, is approached in terms of infinity. Well, so where did I draw that? Let's just look at that. Hang on a second. So as we get very, very large, you'll see there the second one here, the gold one, supposedly approaches a fake number e. Okay, but as we go closer to 0, this one here approaches the number. Getting a terrible pain in my eye right now. The fake number e. Okay, never gets there. So limit theory says that there's a number e, but there isn't. It just assumes that there is a number e. But e is not a number, it's a symbol. Okay? And it's only a constant. The fact that it's a constant is known and used as a number approximation. So anytime you see e and you need to perform an actual calculation where you're going to do something useful, you replace it by an approximation, which is a number, but it's not e. 2.718. Wow, that's not e. It doesn't matter how many digits you are able to calculate, and you can't calculate all of them, even if you could live forever. Now that is a feat that not even higher beings than us can do. And believe me, there are higher beings. I'm asking you to believe me because most of you are too stupid to know this, but I know this. There are higher beings, and I can prove it. Not the topic of this video, but there are higher beings, and they can't do that because they'd have to live forever. All right? So there is that fake idea, that fake notion that e is a number. It's not a number. So let's look at some more proof of that. Well, first of all, there are two binomials. Remember, the one I showed you was approaching 0, and the other one approaching infinity, right? So let's look at the one approaching 0. So if we start off at a high value and we begin to approach 0, the curve eventually, the binomial curve eventually becomes the same as y is equal to e to the x. And similarly, if we had the second binomial and we were to approach an infinitely large value, okay, then it starts becoming also like the expression y is equal to e to the x. And this is so due to the fact that there is an asymptote here, okay? There's an asymptote here between these orange ones. You know, you'd think to yourself that since neither of these representative functions has a limit when x is equal to 0 or x increases indefinitely, it doesn't have a limit at all. E is not a limit. The imagined limits are some number E, and in both cases we have an indeterminable infinite series, and in the latter case we also have unreachable asymptotes. Look, you infinite morons of the mainstream. Y is equal to E. Do you see that? If this orange function could ever reach this guy here, then it wouldn't be called an asymptote. But it's called an asymptote because it doesn't ever reach it, which means there is no way that you can compute the number E, not like this or like this using the first binomial, this binomial here. Okay, so those are conceptual inconsistencies in the sewer or syphilitic brains of mainstream academics. I need a sip of my water. So now, I've written an article here showing you how to derive that function, a binomial, without calculus. It's simply a binomial, people, a binomial of two variables, x and n. And I'll give you a link to this, and if you do all the calculations, and you actually place x is equal to 0 in this function, which you can because it's the same as discarding all the terms in x, okay, discarding all of them. You're not doing an infinite task there, you're just ignoring them. What do you end up with? 1. Therefore, e to the x is approximately equal, not equal, approximately equal to what you see down here, okay? And you'll be able to find this article on my Academia page. Here it is, and I'll place a link to it. Now, in this particular applet, I show you how you actually get these curves, okay? So you start off with this binomial, and as this increases, it starts to become more and more like the exponential function. And similarly, as this decreases, it becomes more and more like the exponential function, but never exactly like it, okay? It's impossible. There's no way it can become like it because that would actually mean you performed a division. You actually measured 1 by 0, and you did so many invalid arithmetic operations. There is no number e, there is no number pi, there is no number square root 2. They're all constants, and we represent them as number approximations. Okay, so where am I going with all this? I know that most of you are morons. The majority of you are incorrigible morons. And your teachers and lecturers are also in that category. For this reason, I'm working on a new, fantastic hardcover book, which will only be available in hardcover, which will explain the most important concepts in mathematics, those of measure and number. And although it's aimed for mathematics lecturers and teachers, it can also be used by students. Okay, it will teach them the meaning of number, how we got numbers, how everything came from geometry, including the arithmetic and including the concept of number and algebra as well, by the way. And it'll be ready in a few months' time, or hopefully sooner, because I'm known to finish things quickly when I really have good health. So that's pretty much it. Click like on my channel. I am persecuted by the mainstream community. At one stage, I used to have over 200 new subscribers. Now it's only a trickle. It's like just a few a month, which is ridiculous. I should have millions of subscribers, since I am the greatest mathematician today, without any shadow of doubt. Okay, so become a subscriber, tell your friends about this, follow me on Academia.edu, and contribute whenever you can. This book, by the way, that I'm writing is not going to be free, and it's going to be sold at the price that's going to sustain me, because I'm currently living in the financial poverty section of humanity. I don't have much to go by every month, and I struggle to get by. I'm not afraid to admit that. It's true. I get a very small pension, barely enough to get through the month. So that's pretty much it. I will continue this and many other topics as my eyes permit. And until next time, I'm John Gabriel, and this is a new calculus channel.